Hey guys, welcome back to the Wave Shooter tutorial series, and we are at tutorial number 10. Nice job, guys, you made it this far. We did set up a camera shake in an older tutorial, but what happened is I don't think it looks good. It works well, it just doesn't look good enough, and I have a simple solution to make it look better than what we had it look before. So we'll be doing that, and then we'll be refactoring the enemy system, which is going to allow us to make more enemies and just build upon the base enemy system really easily. But let's get into it. So we're going to be going into our camera 2D script, and the first thing I want to change is this zoom in intensity. I think I set it to like 0.015 as my intensity, and that was a good value. I found that worked well. I also don't like what I did right here, where I snapped back the position to 320 by 180, because let's say the screen is shaking and it drifted off to a certain point on the screen, it's going to instantly snap back to that specific point, and it just doesn't look as good as I would want it to. So we're going to cut this line out with Control X, and then I'm going to go up here. Let me add a line to scroll over. Enter. Okay, I'm going to do an else. So if the screen is not shaking anymore, we want to do global position equals lerp. I guess I didn't have to cut it. I'll just say lerp global position, comma, vector 2, 320 by 180. That's the position we're moving to at 30% speed. So now we are interpolating our position back to the base position that we were using before. So I think it's going to look a lot better when we have it this way, but we're not done yet because I have to go into the enemy script and we're going to update it. And I think I found 80 as a good value at like 0.2 time. Okay, so now we can run it. We're going to run our arena. You can see right off the bat, the screen shake system looks a lot nicer, and I like this a lot more. I don't know. It just looks nicer than what we had before. And you could change these values if you want. You could go all the way up to 120 or like 0.3 for like 0.3 seconds. See how that looks. But I think 80 at 0.2 is going to be one of the best values. Yeah, because it just has too much extra shake because at 0.3. So if I set that back to 0.2, let's see how that looks. But it's kind of just a matter of fine tuning and figuring out what values work for you. Yeah, I like that. So refactoring the screen shake system. This was an easy way of doing it. There's a Discord user on our Discord server, link in the description if you're interested in joining. Well, they messaged me and they were showing me their screen shake system, and they were using Tween, which Tween is just like the lerp, but Tween actually has more customizable parameters, and they can overshoot values and have different curves. So it's a bit more advanced than lerp, but it does work really well. Okay, so I think that's going to be it for our screen shake system rework. But now let's jump into the enemy system. So let's open enemy.gd and open our enemy scene. So a lot of our enemies are going to be the same. They're usually going to have a lot of the same behavior. When we get hit by a bullet, we want it to turn white. We want to knock back. We want it to lose HP, and we want it to get stunned. All this. So we don't want to be making enemies and copying and pasting code across, because if we have to refactor the knockback script, let's say, if there was a problem in the knockback script and we have multiple enemy duplicates, we would have to change that in every single enemy script, and that is not a good way of doing it, and it's just a lot of work doing it that way. So we're going to be using something called scene inheritance that Godot uses that will inherit the same scene like this entire same tree. Every enemy will have this same scene tree, and they can add more scenes into this tree, but they'll have this same base tree. Before we set up scene inheritance, what we're gonna do is I'm gonna make a new script down here in the file system. I'm gonna right click, new script. We're gonna call this enemy core, and instead of inherits node, we're going to do inherits sprite, or whatever you're using for your enemy. We're using sprites in this case. A lot of tutorials actually use kinematic bodies, but we're not using any physics detection, so we're just using simple base sprites. So make sure it's inheriting sprite, and we can hit create. So now locate your enemy core script, double click it, and we're going to be copying and pasting lots of these base stuff from this enemy script back to this enemy core script. So speed, velocity, stun, HP, blood particles, this can all go in our enemy core script. I'll talk a little bit about setting these properties without having to change the script. So we're going to save that, and now we're going to get some errors in our enemy script because these variables no longer exist in this current script. But what we can do, remove this extend sprite, grab the enemy core script within the file system, drag and drop it. So now you see it says extends enemy core.gd. So it's no longer extending to its base sprite class. It's extending to a script that that we have built, and this script goes back and inherits from the base sprite class. So we're still inheriting from a sprite, but we're also inheriting from our core script right here, which is allowing us to use these same variables from this core script back in our enemy. Now this is a really nice way of doing it, because if we want to add in our variable, we just add it to the script and we don't have to copy and paste it if we have multiple enemy scripts. So that's one of the great ways of setting up scene inheritance. I guess this is more just like inheriting a script, but it works really well. I don't want to copy and paste the movement that we have right here, because the thing is that you might have a different movement system for different enemies. You might have ones that, I don't know, dash towards a player or something. Every enemy, we might not want to use the same move script. We might want enemies to dash towards the player or have different movement systems. So simply copying and pasting this into the enemy core process script might have some problems with other enemies if you're trying to have a different movement system. So the best way I see of doing this is we're going to still cut it and we're going to put in our enemy core system. And in this system, we're just going to be setting up a function. We're going to call it basic movement towards player. And we're going to paste this code in. Saying it wants the delta variable because we don't have the same delta variable we have from our process event. So if I wanted, usually the process event has a delta variable that you can grab and use right here. Problem is this function that we set up, our custom function, does not have a delta variable. So the best way I found of doing this is actually setting a delta argument like that. And then when we call this function, we'll actually give it our delta value. So now the enemy can choose, okay, if we want some basic enemy movement that we are going to be using for this enemy, we can copy this function, paste it right here, and just give it our delta variable. And we can save that, and it's grabbing this function and still moving towards the player with all of this code without having to copy and paste it. Because if we wanted to change our base movement system, if we copied and pasted it enemy to enemy, it's going to become a problem of changing it. That's why we're using this basic movement system towards the player, and this function works really well for stuff like that. Okay, now with HP, we are probably wanting the same thing with the HP camera screen shake. We might want to have a camera screen shake a different value between enemies. We can set that up as a variable. So I'm just going to copy and paste that in. So we'll cut this and we'll paste that into a process function. And you could separate every single one of these into different functions, but I think that kind of gets tedious because in every enemy, you usually want them to die. So you're probably going to have to be like, check HP, basic movement. And basically, you're going to have to put in every function. But if you want to have different enemies that don't have the same HP system, then go for using a different function. But for now, we're going to be using the same movement system. So we'll be using this one right here. We're also not using our delta variable right here. So we can just do underscore delta to tell Godot that we're not using the delta variable. It doesn't really matter, but I find just doing underscore delta can help improve performance. Okay, so now we're gonna go back to our enemy script and let's see what else we want. We have our hitbox area entered where we knock back. We see that we do have an arbitrary knockback value, so we can also set that as a variable. So we're going to cut this and we are going to paste this into our enemy core. So you might be worried that we're copying and pasting a signal into the enemy core, but since the enemy core is inherited from the enemy script, we've already connected the hitbox entered, so it should be going through the enemy core either way. And we do have a problem here too. On our stun timeout, we set it as the original color, and we can easily fix that as well. We'll just paste that in to the enemy core, and we'll fix all this later. Stun timer timeouts, and we can save all of our scripts. So we basically have an enemy core that holds all of our code that we had in our enemy, but now the enemy is using its basic movement towards player as its own code. So we could save that, and let's run it and make sure everything works and we haven't broken anything. And you can see it works. The enemies still move towards the player. They react the exact same way. And that's the nice thing about scene inheritance is if it was working in the original scene, it usually is going to work in the inheritance. But there you go. We have awesome killing enemies, great stuff going. Let's go back to our enemy core and let's fix these arbitrary values and make them actual variables. But before we do that, I'm actually going to talk about exporting a variable. When we export a variable, let's do that on the HP right now. I'll just say exports integer var HP equals 3. So what this basically does is export. If I save the script and I unfull screen it, I go back to our player and you see there's an HP value now in our script variables category. And it's saying HP equals 3, and we could set that in the editor without making any changes to the code. So this is nice if you have multiple scenes and they're using the same script, but you want to have different variables and you don't want to hard code them in. You can just set them as an export variable and you can change those variables within the editor without making any changes. But since we set it equal to 3, the default value in this category is going to equal 3. And we also have to specify our type, which in this case is an integer. That way, when I hit up and down, it's not going to increase like a float. It's going to be whole numbers. Because if I did a float, I save this, now it's going to allow me to do 3.1. If I go back to an integer, I cannot do 3. If I try to type in points, it's not 3.1, it won't work. It'll just round down to 3. So that's the great thing about exporting variables, is you can set these easily. Okay, so we're going to be doing the same for our speed. It's going to be an integer because we're not going to be using values in between. And yeah, we'll just do export int var speed equals 75. Now we can edit our speed and our HP within the editor. Now there's a couple more things that we're going to have problems with. Our knockback, we probably want to have that as a variable so we can edit our knockback. So we can try to set a value for our knockback and set it as an export. The problem with our current knockback system is it's using our speed variable, velocity multiplied by delta. So if our character moves faster, he's instantly going to be able to knock back faster, no matter if we change this value or not. And we're actually gonna fix this right now. We're gonna cut this code of moving our global position with our velocity and speed, and we're gonna paste that right here. We're only gonna do that if the player is not equal to null and we are not stunned. As soon as we're stunned, global position plus equals velocity multiplied by delta. We do not want to incorporate speed in our knockback. And so that will instantly fix our knockback system, where we can set this as a value and that won't be affected by the speed. Now our problem is with the new knockback system implementation, we're going to have to be using a different value than 6, because the enemies are going to move back like 6 pixels when we do that. So if I jump back into the game, let's see this. We're gonna have some enemies spawn in here really soon. I'm hitting him and he's not really moving back. He's kind of just sitting there. He is moving back just a little bit. He's moving back like 6 pixels. And to fix this, we're gonna go back into our enemy core script and we're gonna have to set this value a lot higher. So we're gonna like do 60. Let's see how that looks. So this is knockback at 60. Still not really much. You can still see that they're getting knocked back though. So let's set it to like 6,000. Let's try 600. Let's see how much knockback that will be. And they're saying 600 is a pretty good value. I was thinking it was going to knock back a lot more, but that's like what we were having before. So we'll set that as our default knockback value, but we'll set it as a variable in the editor so we can change that as well. So go back to our enemy core script, and instead of having this as an arbitrary value, we're going to go back to our variables, and I'm going to set export integer var knockback, and we'll set that to 600 by default. And then I can copy this knockback variable name and we can paste that in as our 600. But then we also have a problem with this arbitrary setting up our color value, because that's only going to work for our red color. So if I try to change the color to like, so let's say we set it to a yellow color and then we save and run it. The thing is, it's going to turn back to red as soon as he goes out of his knockback stage, because he turns white and he has to turn back to his original color. So you see how he's turning red, which I mean, that could be a cool enemy that resets to a different color every time you hit him, just like showing a different state. But for right now, that's not what we are planning on doing. So we can exit. If we go back into our enemy core to fix this, I'm going to copy this hex code value so I can get back our enemy at its original color. I'm going to select the enemy, copy and paste the hex code value. That way I have him back at red. So instead of setting him back to this value, let's create a variable to start. Variable current color. Variable current color equals modulate. That gets compiled at compile time as soon as I hit that run button. And modulate isn't going to be set up yet. So we're going to get an error. Oh, modulate doesn't exist. So on ready, make sure if once everything is initialized, then we set our current color to modulate. And this is our modulate color. So now we can copy this current color and set modulate back to current color. And we can run back our arena script and let's make sure everything is working. But you should see it's working the exact same as last time. It's just using more code. So now if I set them to yellow, I'm going to copy my hex code value before I set them to yellow because I want to make sure I don't lose this color value, and I'll set it back to yellow. I'm going to save it. You can run it, and now I'm going to be moving around. The enemies are yellow. I hit him, and he's still yellow, but his blood is pink. We'll have to set it up so the blood will become the color of your current color. So I'm just paste my current modulate back. But now it works with multiple colors, and now we have our enemy core set up. So you're probably thinking this is the exact same as what we had before, but now we set it up in a way where it's expandable. We still need to set the screen shake value though, so let's do that first. Export integer var screen shake. We'll just set that to 120 by default, and we'll set this screen shake value right there. And you can run it and make sure everything works still, and you have enemies correct color, same screen shake, everything works. So let's say we want to add multiple enemies now. Let's get into the scene inheritance, because we don't want to keep having to set up the same scene tree with the hitbox, collision shape, and the stun timer and have to connect that all up. I think that would be lame having to set that up each time. So what we can do is we can do scene, click up here in scene, do new inherited scene, select your enemy.tscn, and we're gonna hit open. Now we have an unsaved scene, so you're gonna see these nodes in the scene tree are grayed out, and that's because they are inherited of these values, and it's saving the enemy's scene right here, and it has a little scene icon, and this will take me back to the source scene that's inheriting from. So these are all being inherited from this current scene, the enemy scene, but I can still edit these values. Like, let's say I wanted to change the collision layer. Well, I could do that to this one, it just won't affect the original enemy. But if I go to the current enemy and I say, okay, I want the color of all the enemies to be yellow. I save that, I go back here, and now this one's yellow. Now I set it back to my current value and I save. Now this one's back at my current value. So the thing with this system is if you have the first enemy and you make changes to the first enemy, it will make changes to all of them. So either you inherit from this one again, let's say with this one, we're actually going to be using this one as the enemy 1. We could just inherit back at enemy 1. That way we could change the color of this one. Say we change that back to yellow. We could save this one. You'll want to save to its own scene. That's okay. We can hit enemy1.tscn, hit save. And this one's still going to be red because this one is its own kind of scene, but it's just going to be inheriting from this base scene. So now we can rename this enemy base and save this one. And then with enemy 1, I'm going to set it back to its original color value, and then we can save here. And that's how you can deal with setting up the original enemy without having to change all of the other inherited scenes. But we have our speed, we have our HP, we have our knockback, and we have our screen shake. And we can also set up our own scripts, because right now we're using the old enemy script right here. And I'm actually going to rename this enemy script so we have a good understanding of what it is. I'm going to rename it to enemy simple. Let's call it enemy simple. Rename. And it might say another resource is loaded, enemy simple, and it's gonna have an extra script that's empty up here. That's because we renamed it and it's just seeing the old script still. So we hit close. That's just fine. So now it's called enemy simple.gd. And so we could set up different scripts for each enemy. Now that we have enemy 1, let's actually make another inherited scene. So go back to your base scene, do new inherited scene, and make sure you have selected the base scene and hit open. We're gonna call this enemy 2. Let's make our second enemy. And let's say we want to make him yellow like we had before. We have our yellow enemy and it's enemy 2. Let's say the yellow enemies are actually a lot faster. Let's go like 140 as their speed, and we'll just set their HP to like 1. And we can set knockback to like twice as much too, like 1,200. And screen shake we could set quite a bit lower. We could set this to like 70. We'll go 90. And then you hit Control S and you save. We already made a new enemy. We didn't have to change any code. We just had to change a couple parameters in the script variables. So if we wanted to have a different movement system, we can't just change the enemy simple script because that would change this enemy script, the enemy 1, because that's it using this same script. So if we wanted to do a different movement system, we'd have to clear the script right here, add a new one, enemy, we can rename it, I don't know, enemy dash.gd or something. And then you'd go into enemy core, you add your own function for the different movement system, like basic dash movement. And then you call that in this new script. You'd have to make a new script and you call it in the process, make sure it's inheriting, and you do that all there. For now, I'm just gonna leave it as enemy simple.gd and leave that there. But if you want to have different movement systems, you just do it that way. But the only problem is we have new enemies. We're gonna have to fix our blood particles. The problem is we can't have it as the same color as the current enemies because it's gonna be hard to see the enemies above it. So I'll have to figure out a solution for that. It should just be lowering the values. But for now, we'll just deal with the normal blood particles. But we're gonna run into a problem. It's gonna only spawn the original enemy, enemy 1. We want to spawn enemy 1, enemy 2, and so forth. So I found an easy way of doing this. We're gonna be using our same export variable system, export array, and in this array, we are gonna be using packed scene. And so a packed scene is like one of these tscn files right here. Like enemy2.tscn, that's a packed scene. And then we're gonna do variable, we're gonna call this enemies, and we're gonna save that. So what this is gonna do is if I go to my arena node 2D, it's gonna say enemies. This is array size 0. I click on it, set it expands this, and I can set size to 1. Okay, we want 1 enemy to spawn. Or we want 2 different types of enemies spawn. Then I can load a pack scene, enemy 1. It will load this one into the array. Now I can load another one, our enemy 2, and it'll load our enemy 2 in the array. For some reason the previews don't look right. Enemy 2 should be yellow. I think it's a problem with scene inheritance, but it will be yellow. It's just going to show up as red on the preview. But they're still not going to spawn the enemies, but we do have a variable that has our enemies contained in it. So we no longer need to preload this, because now we are going to be using this one. So when instancing a node, we want to pick a random enemy within our array. So to do this, before I change this, we're going to have to set up a little variable up above here. We're going to call this variable enemy number. It's going to pick a number from what these scenes are, because it numbers them 0 to however your size is. So 0, 1, 2, 3, 4, and it'll go all the way down. And you can see our size is 2, even though it only goes up to 1. So the 0 index in our array is enemy 1. This 1 index in our array is enemy 2. So we can do this to randomize the enemies that are spawned. So enemy number equals rand range. We're going to do 0, because that's our start, is the 0 index, to enemies.size -1. We can't just do rand range though, because it'll give us values in between. We want integer values. We don't want float values. So we'll have to do random range and do the parentheses around this random range. The reason why we have to subtract 1 from our enemy size is here. If I show you, it says enemy size is 2, but our last index is 1. So if we subtract that, our last index, our enemy size will actually be 1, but it will align with our last index. And we're going to be using this indexing system. So if I do enemies, I put bracket enemy number. So let's kind of break this down piece by piece. We set up an enemy number variable. We do random range. We make sure we round this so it's integers. So we get 0 or 1 in this case, because we only have 2 enemies. And when we're retrieving our index, like right here, it has to be within 0 or 1, even though our size is 2. Because if we write 1 in our index, it will retrieve this scene, which is the enemy 2. If we write 0, it will get enemy 1. So that's why we have to do enemies.size -1, so it will align with our array values. This is a bit confusing, so I hope you guys kind of figured out how this works. It's just doing array values and aligning them correctly and getting a random enemy from those index values. And this will basically return the enemy that we selected from our enemy number. So if I save this, now I run it, enemies are going to be spawned randomly now. Oh, we got a yellow enemy. Let's shoot him. He knocks back quite a bit. See if we get any red enemies. Oh, there we go. We got red enemies too. I think I should make the yellow enemies a bit faster. They don't seem fast enough. And you can see it randomly selects the enemies and it all works. The only problems we have right now is the game is way too difficult. So if I go back into our arena script, I'm going to set the difficulty, the wait time, instead of minus equals 0.1. Let's just make it slowly ease in. I feel like it eases in too much. So let's actually minus wait time by like 0.25. Let's try that. 0.025. That way it slowly eases into more and more enemies. We got a yellow enemy. They still have red blood. We'll fix that next tutorial. Don't worry about it. Spawning in a bit more rapidly. And I think the difficulty curve now is a lot better with having a lower value. And we have enemies spawn in randomly. And we have enemy inheritance. So I think this is really good because now you guys can actually add a lot more content really easily within this project. We'll fix the blood particles. It's gonna take a couple things with color because we're gonna have to make it a bit darker so you can actually differentiate the enemies from the blood. And we'll also make the blood fade out as well. So I hope you guys enjoyed this tutorial, and I'll see you guys in the next one.